Welcome, everyone. We're letting people, giving everybody a minute to join, and we'll start at the top of the hour.
Keith, I think you're muted.
Thanks, Brenna. Start that again. Welcome to the Institute for Catastrophic Loss Reduction's Friday Forum for Friday, September 8th, 2023. I'm your host, ICLR Chief Engineer, Dr. Keith Porter. This is one in a monthly webinar series hosted by ICLR, Canada's leading source for disaster resilience knowledge. Each month, we present recently completed research or other useful knowledge related to ICLR's mission to help make Canada more disaster resilient. Last time, we brought you Dr. Tegan Hobbs of the Geological Survey of Canada, who presented the new National Seismic Risk Model. The slides and video are available at ICLR's website, www.iclr.org/workshops. Next time on October 20th, 2023, we will have three speakers, Becky Denlinger, Veronica Scotti, and Matthew Godso, who are going to speak about modernizing Canada's Disaster Financial Agreement Arrangement, or DFAA. It's my pleasure to introduce today's speaker, Brenna Meisenzahl, who's going to speak about the accumulated damage from high concentrations of small hail, which I think of using her catchier, less formal title, Small Hail, Big Problems. She's going to tell us about research that challenges the notion that only big hailstones matter to roof damage. Brenna is a meteorologist working as a research project scientist at our sister organization, the Insurance Institute for Business and Home Safety in Richburg, South Carolina. She does research on wind and hail, both what happens in nature and how they affect the built environment. I'm particularly interested to hear what she's got to tell us today about how large quantities of small hail lead to notable granule loss in roofing shingles, which makes roofs more susceptible to large hailstone damage and shorten the lifespan of the roof. Before our speaker begins, here's our agenda. Our webinar will last 90 minutes. Our speaker will present for about half that time. Then I'll moderate Q&A for the rest of the time. Please feel free to chat your questions into the Q&A box. I'll try to pose your questions in the order they appear in the Q&A box. If we have a lot of questions, I may only pose your first question, then move on to others, then circle back to your additional questions. Our webinar is recorded, and ICLR will post our speakers' slides and a link to the video on Monday or so. So if you have colleagues who couldn't attend, please let them know. And with that, I will turn it over to Brenna.
Hello, thank you, Keith. Appreciate it. Again, my name is Brenna Meisenzahl. I'm a research scientist at IBHS, and today I'm going to talk to you about hail. So for those folks who don't know IBHS, we are a nonprofit research lab funded by insurers and reinsurers, researching how severe weather affects homes and businesses. We help mitigate damage to residential and commercial buildings by conducting large and small scale testing on buildings and building materials. Our research perils are wind, rain, wildfire, and hail. And as I mentioned, hail is what I'm going to focus on today. And before I dive deep into the details of the research experiment, I'd like to start with some background information on our hail field program and our hail impact standard that was developed in 2019. In severe convective storms, hail accounts for about 70% of annual loss and can cause between 60 and 80% of the damage by by these storms in a given year. Compared to wind and tornadoes and lightning, hail is the #1 issue here. And according to a study from Aon, done I believe in 2022, hailstorms have become a $15 billion annual problem. That's a big deal. To help mitigate this problem, IBHS developed a realistic test standard to replicate real hail damage and analyze it at our lab. We started by evaluating the existing test standards and identifying where the flaws are in those standards and how we could do better, what we can improve on. Step 1 was to obtain measurements of hailstones from the field. Once we understand the characteristics of hailstones, we can manufacture our own. And 5 years of field data has put us well on the way to developing a new, more realistic hail impact test protocol. We learned how hail impacted roofs and how hail damaged roofs, and how to test shingles against realistic lab manufactured hailstones in a controlled and repeatable way, thus creating our IBHS hail impact test protocol. So let's back up slightly. What led us to collecting our own data out in the field? Why didn't we use previous data sets that were already out there? Well, the issue is there's a big gap in data. There weren't already data sets available, or there wasn't as much. Well, there was a lack in the measurements of hailstones at the time, no quantification of hail strength and some density challenges. So we needed to fill that gap in order to manufacture our own and create realistic hailstones. We didn't know much about hail characteristics, and prior to in-situ data, we had COCRA's hailpad data sets, which did point us in the right direction, especially on how high plains front range hailstorms typically have more hail per square foot. So that gave us a start. Onto our IBHS hail field study. The first few years were focused on collecting measurements of hail and determining what properties we needed to accurately replicate hailstones in the lab. We've done that.
Sorry to interrupt, Brenna. We're back to the editing mode of, there we go, thanks.
Oh, I wasn't sure what happened. So yeah, we first started with determining what properties we needed to manufacture hailstones at the lab. In 2016, we added a 3D laser scanner to the field deployments so that we can contain those hail characteristics save those hail characteristics, and then we're able to actually print out 3D hailstones at our lab. We also developed a network of impact astrometers, which I'll give a little detail, I believe, on the next slide. And then we moved on to, mapping hail swaths, trying to understand the size distribution throughout the storm, and comparing to radar scans. Looking ahead, kind of what we're also doing right now, identifying environmental differences in hailstones and the regional differences in their characteristics. So a quick few things of what we measure in the field. We have our maximum, we measure diameter in maximum, minimum, and intermediate. We take the mass of hailstones, and we also collect compressive strength using our crushers. So our distrometers, we have a fleet of 24. They're all equipped with a piezo sensor at the top. And what happens is when hail is impacted, when hail hits the distrometer, it hits that impact plate, it records a vibration, and the vibration can be transitioned into a kinetic energy. And because of the data, the rest of the field data that we've been able to collect and what we were able to produce at the lab, we can identify the size of hailstone that hit the distrometer. More so, when we do deploy these, we do try to get in a good swath distribution. Since we have 24, we can get a pretty good visual. So manufacturing hail in the lab, we have our, taking the field into the lab, as I mentioned, conduct our own testing. We need to actually make our own hail. We do not, we do that with our hail machine. You can see similarities between our natural hailstones or the natural hailstones and our manufactured hailstones in that cross section. And the secret here is we infuse our water with CO2. So it's not just pure water as what's shown in the standard test ice sphere. There are tanks on the top of the machine that house the water where it's infused, and then they run different breathe cycles to replicate the different growth periods seen in natural hailstones. And currently our machine can manufacture 1.5 inch and 2 inch hailstones, both soft and hard ice. So there's a couple different, because of that compressive strength that we're able to identify in the field, we can make 2 different recipes, those of hard hailstones and more of soft, compressive, ductile hailstones. And 2 of the machine vision applications that we use to analyze the data from the shingles. For most of our impacts, we use our Nemesis application, which takes multiple images of each impact and provides quantitative results on the depths of, say, dents and ridges and tears and granule loss. The Keonz is a newer tool with better accuracy, but it's still in its pilot stages as all the settings are getting configured. It's not an apples to apples comparison between Nemesis and the Keonz. Nemesis can use image processing where the Keonz is measuring directly off the shingle. And for both these applications, the shingles must be cut off in order to analyze. So we cannot, once it's time to analyze, we cannot reuse these panels because they pretty much get broken down and broken apart. And I bring this up because in the details of the experiment I'm going to explain, we do use Nemesis as part of it. So I wanted to have a good detail. I wanted to share with you some details on that. And then this brings us to our impact resistant shingle performance ratings. This is publicly available, but the options to rate a product for a given category are, for a given category and for overall, are poor, marginal, good, and excellent with their associated colors. I mentioned this because as a part of the high concentration experiment, we do compare our results to this performance rating. That's why we also use the Nemesis application in a portion of it as well. Especially because there are few products from this rating system that we used in our high concentration experiment, so we can do a direct comparison between the two. And moving on to details of the experiment itself. Previous data collected by Kokoraz and other field campaigns show hailstorms with high concentrations of subsevere and marginally severe hail are more common than thought to be, far more than storms producing large hailstones. In an analysis of insurance claims, it's shown far more asphalt shingle claims are occurring due to hail sizes previously thought to not affect most roofing materials. This study investigates the cause of these claims in a way to understand the damage that the small hail can create. That's what we want to do. We want to bring focus into the small hail and its potential damage. So here's a couple examples from in the field. So as I mentioned, we underestimate how many subsevere stones fall during a given storm. And through one of our previous field deployments, we're able to provide more evidence for this claim. And an example here captured over 900 impacts of hailstones around a half an inch in size over the course of 10 minutes. And this is on a 1 foot by 1 foot distrometer plate. And if we move to another example, again, this is from one single distrometer from one single storm, we see this storm collected about 10,000 impacts within 20 minutes, with roughly 3/4 of an inch to 1 1/4 of an inch, which is the sizes of hails that we are looking at testing. And I just wanted to play this video just to show an example. Oops, I think it paused. Just to show an example of kind of what we've seen in the field. And yes, we've seen 10,000 hailstones on one distrometer. We can't recreate that many hailstones in our lab. We don't have the manpower. It's just not feasible. And impacting 10,000 hailstones on a hail panel is quite a lot. There we go. So our hypothesis, through this hypothesis, we're trying to answer quite a few questions. Do high concentrations of small subsevere hail lead to notable granule loss? How do products perform over time after these events occur, or multiple of these events occur? Do impacts from large quantities of small hail make larger hail events worse for shingle performance? Will these events produce enough damage to result in an insurance claim? We need to understand the granule loss problem on asphalt shingles. So this was our test plan. For the first phase of testing, we had a total of 12 panels, 6 products. So there was a twin of each. One set of 6 was our experimental group. The other one was our controlled. The experimental group sat in our IBHS aging farm, and they were naturally weathered for 1 year. And then we had another group of the other 6. They were stored. They were not weathered. They were stored in a temperature controlled room for a year. After that 1 year time frame was up, they were taken down. We took pre-photos of the panels. Then they were impacted. Well, after impacting, again, photos were taken of the panels. So we have pre-impact photos and post-impact photos. And we do a little bit of image analysis to see the granule loss just after the first round of impacts. And then that process is repeated 1 more time. Again, after the second time, we do another image processing analysis, and I'll go into more details of exactly what application or what tools we used for that. They were also aged for a 3rd year, and then we impacted them following the IBHS hail impact test protocol, which consisted of 42-inch hard hailstone impacts. Once that was completed, we did another round of image processing, and then this is where the Nemesis application came in. Because we use Nemesis for the impact test protocol, so we had to use it for this as well. And this also would give us any sort of dense scores that we wouldn't have gotten with the image processing, because the image processing only picks up granule loss. It's not programmed to pick up depths of dents or ridges or tears. So these are the test specimens. As I said, they were made up of 12 total panels, 6 different products. Within those products, we tested a wide variety. So we had some conventional non-impact resistant products, as well as impact resistant products. There's a mixture of 3-tab and architectural, and you also notice a variety of shingle color, but that was not a consideration for this testing. Our photo rig. So this was a rig that we just developed in-house, where we capture our pre-impact and post-impact photos. The rig is set up with 4 bright LED lights up at the top. blackout curtains around the side so that we remove any shadows that are on the panels and we can capture just the smallest details. There are 4 camera molds above each quadrant of the panel, and they just hold a little point and shoot. So the point and shoot camera is moved from one quadrant to the next. And because of the camera rig or the cameras itself only being 3 feet above the panel, the camera can't capture the entire panel itself, which is why we have to split it into 4 different quadrants. And you'll notice some checkered squares placed around the panels. Those are used for image processing reference points, and I'll give a little more detail on that in a bit. So, I mentioned our hail machine, which is generally how we create or manufacture hailstones. However, this experiment, we used ice molds and tap water, since we don't have the capability to produce this small of hailstones through our large machine. As I mentioned, we only do 1.5 inch and 2 inch hailstones. We also needed that machine to continuously make 1.5 inch and 2 inch hailstones for other projects going on. So this, because we needed such a large quantity of these hailstones all at once, this was the best solution, was to use molds. And density differences between our manufactured hail and the molds are negligible due to how small the hail is. So like I said, we used water infused with CO2 for the manufactured hail. However, we just use ice for the molds because they're so small. Once water's poured in, they're sealed shut, kept in clamps or clamped shut. They're placed in freezers for a few hours. Once completely frozen, they're taken out and either stored in the freezer for up to 24 hours or they're used immediately. Onto the impact of testing. Each panel is impacted with 300 3.25 inch hailstones and 201 inch hailstones for a total of roughly 500 between all of them. Again, we know now that this does not represent a mild, or this, we know now that this does represent a mild high concentration of subsevere hail event. There, as I mentioned, it's quite difficult to make and shoot thousands of hailstones just with our lab capability. So we did a mild event to just compare those. There's no set impacting spot on the panels. Each impact was meant to be random, so it looked realistic. And before impacting, each stone is weighed and measured in diameter, just like we would any other with any other project that we're impacting, any other panel that we're impacting. When shooting out of our pressurized cannon, the speeds of the stone is captured, and all these parameters will give us a kinetic energy for each impact, which is stored in an Excel file. So once impacts are complete, as I mentioned before, there's a post photo of the panels are taken, and at which time we can start the analysis process. For this project, this was done through image processing, utilizing some of the applications in the toolkits in MATLAB, specifically the image processing toolkit. The pre and post photos are overlaid on top of one another, and the registration estimator, one of the applications shown on the left, identifies the common points in the photo to properly align them. This is where those checkered squares kind of come into play. Some cropping of the images is done as well after this to remove any dark areas around the edges, anywhere where the photos may not have completely aligned. We remove those and disregard them. After cropping, we move on to the color threshold application, which is your image on the right, where we manually adjust the RGB pixels to only show red, which is indicated by that blue shaded area. Red indicates differences between the overlaid images, aka the missing pixels or the missing granules. to make sure we are correct in our adjustments, we check the panel itself against what we're seeing on our in that program. So we're physically standing in front of the panel and double checking, because this could lead to some human error if it's not correct. It eliminates or helps eliminate some of the error. We cannot use, as I mentioned, we have our Nemesis application. We cannot use that application for this process since the shingles must be cut out. And they were impacted again. So this program, or these toolkits, were taught to me by Dr. Faraz Hadiati. He's one of our research scientists, and he's very well versed in image processing. So he created a small program to run these images pretty quickly through image processing. At the end of the image processing, we get some numbers. So since I mentioned, since each photo analyzed is one of 4 quadrants on the shingle panel, their data is combined to get the total area of granule loss of the entire panel. We compute the area by taking the number of pixels taking the number of pixels missing by the ratio. The ratio is the area of the checkered squares, or our reference points. This gives us an estimated area of granule loss for each panel in inches squared. So why do we use machine vision to analyze these panels? One, no one wants to count the amount of granule loss by hand. 2, which is the main reason, some of this is not actually seen with the naked eye. There are some panels that you can clearly see granule loss, and there are others where I could tell that it's packed. One of those examples shows a completed.
Sorry, Brenna, your audio is really breaking up. Do you want to stop your camera to maybe save a little bandwidth? Sorry, your audio is broke up for the last 30 seconds or so. Do you want to turn off your camera and maybe save a little bandwidth? That I'm not actually certain that works, but
oh yeah, sure.
Thanks.
Sorry about that. Okay, so I'll start off with, did you catch the end of the previous slide? I'll just start off with this one.
No, we lost about 30 seconds of the previous slide.
Okay, sorry about that. This slide just explains what we how we compute the area. The color threshold, the image processing toolkits from MATLAB give us the number of pixels, which are those red missing pixels that I was showing on the previous slide. And we take the number of missing pixels and we divide it by the ratio. The ratio is the area of the checkered squares, which are, again, our reference points, and this gives us an area of granule loss. And why do we use machine vision to analyze these panels besides not wanting to count one by one each granule that's missing by yourself? The main reason is because half the time you can't tell that these shingles or these panels have been impacted by hail, at least in our small, mild case on a single panel. There was damage to them, but it was hard for us to see it. So we needed that image processing side of it. There were others that you could clearly see the damage on them. And this is kind of one of those examples where if you're looking at this panel, you can see a little bit of damage, but not as much. And I'll show in a minute a panel where you can clearly see damage to it, and it was one of our worser performers. So this image shows a product that has completed all impacting. So that's both rounds of 500 hailstones, and then the third round where it was impacted with approximately 42-inch hailstones to mimic our hail impact test protocol. And can you pick out all the granules lost on this part of the panel? I mean, I can pick out a few, but no, it's pretty hard to see. So on the right-hand side, you'll see the processed image, where you will see those red pixels, indicating the missing granules, which if you match that to the picture, it matches up quite well. And all in all, this product did well compared to the others. This was our good performing product. And just to note, this this is an impact resistant product. From our experimental group, the two images I'm going to show you are both from our naturally weathered experimental group. It is listed on our impact performance rating that I mentioned previously, where for granule loss, it was listed as a good performer, as well as a good performer overall too. So this was a pretty good product listed on our shingle rating. Onto this example. Again, this is one of our worst performers. It's clear here where the product was impacted. The damage is visible to the naked eye, and in this case, we have both patch and individual granule loss. This product, like the previous one, is also an architectural impact resistant product from our experimental group. And if you think this is a poor performer on our performance rating, surprisingly, you'd be wrong. This is actually a really good example of our hypothesis being correct. Asphalt shingles can be more susceptible to damage from large hail events after it experienced a high concentration of subsevere events. When this product was impacted with just 2-inch hail, it performed decently well, as was the result for our impact rating. I believe it had a good rating. But when you add in small impacts and then impact it with large hail, you see a completely different story. As for the results, or some of the results, each row in this chart is a different stage of the experiment. We have our round 1, round 2, round 3. We also have our baseline impacts, which include those from the impact performance rating, which were only impacted with 2-inch hailstones. The controlled group, which again was our stored panels, and then our naturally weathered experimental group. And on average, we see almost 3 times the amount of granule loss for our controlled group compared to the baseline. For our naturally weathered group, we see almost 10 times the amount of granule loss for that group compared to the baseline. Now, these are an average of all the products tested. Some had lower granule loss, some had higher, but we still see a huge spike in granule loss once we get to round 3. And there's a big difference between our weathered and non-weathered panels. And let me remind you, this is an extremely mild, high concentration case we're replicating. Imagine the damage you'd have, or the amount of granule loss you'd have if you used 10,000 hailstones for this project instead of 500. That's not good. Some key findings of our research: hailstones measuring 1 inch and below can cause nearly 30% of the granule loss of 2-inch hailstones. Though smaller stones individually cause less damage, they are far more common than the rare, large gargantuan hailstones, resulting in the vast majority of granule loss coming from small stones. When it comes to asphalt shingles, there's approximately 10 times more susceptible to damage after exposure to natural weathering and small hail impacts when compared to new asphalt shingles. Some of the damage is clearly visible and could trigger an aesthetic-driven claim. It's visually going to drive claims. Just to note, there were no dents or tears seen as a result of the high concentration impacts. This leads us to believe that these events would likely not cause a water entry issue on their own. There's more testing we'd like to do regarding water entry to see if it's an issue with shingles, with shingle degradation. We have completed the testing on these 6 products, and we have moved on to a new set of 9 products. They've just gone through their first round of impacting. So once we start on the analysis of that, we'll kind of see how those products compared to these ones. The goal of this project was to shed light on sub-severe hail to understand the damage that it can cause. With that, we have found these types of events can reduce a roof's lifespan and make it more susceptible to damage from large hail events in the future. And with that, I'd like to say a huge thank you to ICLR for having me and allowing me to do this presentation. And I'd welcome any questions at this time. Also, sorry for a little bit of the network connection issues.
That's all right, and thanks for soldiering through your presentation despite whatever's going on in the background. As distracting as that can be for an audience, I know that it is much harder to present while there's a whole bunch of stuff going on behind you. So, and I totally understand that when you are that sometimes you don't have complete control over the environment in which you are presenting. So good work despite the challenges. Thank you so much for soldiering through.
Thank you.
I have while we wait for people to sort of digest and ask you questions, I have a few, and starting at slide 25. That's the one where you've got the 3 different cases and you show the 10 times that one right there. No, that one right there. So could you explain how we know is it in this information how we know that large hail on naturally weathered panels without the preconditioning, what did you say, sub-severe impacts, how we know that they are different from your third column here?
Sorry, do you mind?
Sure.
Sorry,
sure.
I think I misunderstood.
Right. So the third row, the one that says round 3 large hail, if I understand this slide correctly, you impacted in the third column, you've got weathered panels and you hit them with 2 rounds of small hail, and then you hit them with 1 round of large hail.
Correct.
And
yes.
That leads you to 200 square millimeters of granule loss.
Yes.
So if there had been no round 1 and round 2, but the same naturally weathered panels, do we know from other data, or is it here and I'm just missing it, what kind of granule loss you would get from the large hail without the?
Yes. Sorry. So all of our panels that are taken from the round 3, the baseline panels, those were all naturally weathered.
Okay.
They were. They came from our aging farm. They were naturally weathered and then impacted.
So do you have data here that says, okay, if you just hit it with the large hail, you get less than 192 square millimeters? If you just hit the naturally weathered shingles with large hail, but no round 1 and round 2, do you get less than 192 square millimeters of granule loss?
Sorry, I did mess that up. I'm thinking of our impact ratings. But yes, you were right that the baseline, I apologize, that was not what those panels were not weathered. We didn't, those were taken straight from packaging and impacted. We don't, unfortunately, have in here, we don't have results from just being impacted with large hail after it was weathered.
Uh-huh.
So more of like a experimental baseline. We don't have that in here. We do have some data. I don't know it off the top of my head, but we do have some data from our aging farm where we did do pulls after 5 years of, or harvesting of some panels after 5 years, and then impacting them following that, the IBHS impact protocol. I don't have the data in front of me, but yes, this baseline was not from being weathered.
I mean, the problem with this slide is that there's two things going on here. First, there's the pre with the small hail, and then there's the aging, and the 9.6x sort of reflects both things. And you can't tell from this slide that it is the preconditioning with the, sorry, I keep using that word, the round one and round two that makes the difference, or if it's
Right.
the aging or some combination. I'd be really interested in knowing and in seeing you, sort of pull apart those two effects to really show that it was that the small hail, made the difference between 192 square millimeters and some smaller number if there were just naturally weathered panels just hit with the large hail. But
Right.
anyway, something
No,
to consider.
it's a good point. It's a good point to bring up, and it's something we can look into when we do our analysis side for the next phase, even analyzing some of the previous data from this too, and adding more details to that.
Yeah, great. That'd be wonderful. Let's see. So still waiting for questions, but tell me about how you think your research ought to affect the claims adjustment process. As you pointed out, you can't tell with the naked eye how many granules are lost, but do you imagine any change in the claims adjustment process after a small event where it's just small hail, and no big, bruises like we see with big hail?
I think that depends. Maybe not after the first storm, but again, that depends on the concentration of hail that you get in that storm. As for insurers, we'd like them to just to kind of consider or pay more attention, I guess, to the smaller hailstones. I'm not at the liberty to tell them what to do. All I can do is give them this information and hope that they take this into consideration in their CAP modeling and kind of trying to understand their claims better. But
sure.
Yeah, again, I think it depends on the concentration size of hailstones in a storm, and it also may depend on the age of the roof. That's why we're trying to weather the panels. Again, we can't weather panels for 10 years necessarily and then go back and do this, but I think the concentration has a lot to do with it.
And actually, that puts me in mind. I mean, you say we can't weather the panels for 10 years. We can't do it naturally. But, I know from other disciplines where, you want to test PVC pipe, which is susceptible to ultraviolet light. And I guess in sort of somehow the same way that asphalt shingles are. But anyway, PVC ages and gets more brittle when it's subjected to UV light. Couldn't we? Is there any aging protocol that artificially ages asphalt
Yeah,
shingles that you know
so
about?
we have two artificially aging machines at our facility. We have like a QUV machine, but we haven't figured it out correctly, how to make it degrade or how to make it replicate actually what we see in our aging farm. That's some ongoing projects that we're working on. we're just not there yet to be able to do it, because we would love to. We'd love to not have so many products on our aging farm and have to wait 10, 20 years to study them.
Right.
So,
Yeah. Let's see. You told us, you mentioned cocoa Ross a couple of times. I'm familiar with it because I had to read about it. But can you explain to our participants what cocoa Ross is or was, what data they collected, how much data, maybe sketch out its limitations?
yeah. So COCORAS is a community, it stands for Community of Collaborative Rain, Hail, and Snow Measurements Program. For us, they were using hail pads and collecting data on hail. So pretty much a hail pad is, it's just a 1x1 square foam padding that you put out there just like we would a impact astrometer, but you don't get, the data you get is obviously different. There's no instruments hooked up to it. It's just getting the shape of the hail and then the concentration of the hail in that small 1x1 square. I honestly don't know the amount of data we have in COCORAS, or we know of in COCORAS. I just know that for us back in 2010, 2012, there wasn't enough of it. There wasn't a lot of it, but it still helped us point us in the right direction. Helped us get to where we are with our field program.
Cool. We got a question from our colleague Ron Stewart. Hi, Ron. He asks, your small hail was made up of spheres. Do you think that real small hail with knobs, bumps, etc., plus spinning could lead to more impact?
That's a great question, and we do get that question a lot. We don't know. We make ice in spheres at the lab because it's easy, it's repeatable. Or the damage is repeatable. We had an intern this past summer work on creating molds based off of some of the 3D scanned hailstones that we got in the field, and pouring our water from the machine, any leftover CO2 infused water, pouring it into those molds, and trying to figure out how exactly to shoot them through our cannon, because our cannon is pressurized, but it only fits. It's just got a cylinder, and it really only fits those circular hailstones. So there's a lot of R&D to figure out a cannon that would work. So there is some pilot testing going on. It's also hard too because we can't predict what side of the hailstone is going to hit. We can't, if we want to get one lobe on one end of it to hit the panels, it might not, because it tumbles. Obviously, once it comes out of the cannon, it'll tumble before it makes impact with the shingles. So we're in a pilot study of that, but we are working on it because we do get those questions a lot, and we do also want to understand: are those lobes coming off the hail? Is that actually causing more dents? Is it making Is it making the damage a little bit worse?
Thanks. Greg Steed, I'm not sure if I missed it, so I apologize if I did. Is there data from this research showing the benefits of class 4 impact resistant shingles versus standard shingles? And if so, how big a difference are we seeing?
So class 4, so you're just talking about the impact resistant shingles.
Yeah.
Yes. So as I mentioned, we do involve impact resistant shingles, both this image and this next slide. These are both impact resistant shingles. We're using non-impact resistant and impact resistant shingles to see if there's a difference between the two. I haven't been able to figure out if there's a huge difference. We also only tested 6 products, 2 of them being non-impact resistant. But like I said, these are both impact resistant panels. One shows pretty I'd say minimal. I don't want to say minimal damage, but is a good performer. Is not showing as much damage versus this other impact resistant shingle, which is rated good performer, is rated as a good performer on our impact in our performance ratings. But there's some pretty noticeable damage here, some pretty bad damage.
I'm so excited by your development of a machine to create natural hailstone. Because, sorry, apologies in advance to the audience because I'm going to nerd out on some engineering here. In the past, before IBHS developed its new test protocol, one of the leading test protocols was to drop steel balls from various heights, steel balls of various diameters from various heights onto the shingles, and then to see what happened. And the way we chose the heights and the size of the size of the steel ball was the same as the diameter of the hailstone that we were interested in, and the height was chosen so that the total kinetic energy right before the steel ball hit the shingle was the same as the kinetic energy of a hailstone falling from a great height. And that's how we sort of matched those up. But there's a principle called the conservation of energy. It's a physics principle. And it says that basically, as we apply it here, that some of the energy gets transferred from the steel ball or the hailstone into the shingle. And some of the energy gets converted to mechanical energy as you have to crush we saw one of your hailstones sort of exploding as it hit a shingle in one of your tests. And there's only so much energy. Yeah, you're going to go back to it. Great. There, right there. So there's only so much, all the kinetic energy has to go into either what gets transferred to the shingle or what happens to the hailstone just after impact. So some of the energy of this hailstone gets converted to mechanical energy of crushing the hailstone. And engineers and other people have all sorts of mathematical terms to quantify all of this. But could you tell us about have you done research to measure those things? How much energy goes into crushing the hailstone, or have you measured differences in the coefficient of restitution between a hailstone hitting a shingle and a steel ball hitting a shingle? Basically, what I'm trying to get at is the strengths and weaknesses of that older test protocol that says, let's just match kinetic energy of the steel ball versus the hailstone. Can you tell us a little bit about that?
Right. I think I'll talk about some things that I do know. But I think Dr. Ian Giammanco, and probably Tanya, they were the ones that looked into the UL 2218, the steel ball test you're talking about. They're the ones that dug more deeper into those details and created our Canon system and our manufactured hail system. But yeah, I mean, the strength of hail is so important. That's why we bring crushers out into the field to measure the strength of them and get their force of crush, the force it takes to crush them per pound. And it's really interesting because, I mean, for this past year, for an example, we saw these 3-inch hailstones that were huge. They were really, really soft. They were compressive, they were ductile, they were really soft hailstones. You'd expect a 3-inch stone, to be hard. It wasn't. I mean, we've crushed 2-inch hailstones, 3-inch hailstones in the field that are some of the hardest ones that I've seen. But then again, you get these 3-inch hailstones and they're pretty soft. But we don't necessarily know why that is yet. But going back to kind of the UL 2218 and kind of the differences, So the steel ball test, I mean, the one main thing, the difference between the steel ball and hail is their weight. Their density is different, their characteristics are different, their weight is different. Steel ball is so much heavier than a 2-inch hailstone. And when it hits the panels, it crushes it crushes the hailstone. It doesn't, or sorry, it crushes the granules. It doesn't displace them like a hailstone does. And when you see the markings from the steel ball hitting the shingles, the granules, there's this, it's like white and powdery substance from the granules being crushed, which that's not what realistic hailstones are going to do. And again, too, with the test standard, you have to impact the same spot twice, and then you have to check and see if there's a tear in the shingle, and that will tell you if the product either passes or fails. And there were a lot of products that were passing this, and then when we did this at our facility, every single product that we tested failed. And the reason being is because we don't take products directly from the manufacturer. We go to Lowe's, we go to Home Depot, and we get the products that are off the shelf that any other homeowner is going to buy. But yeah, just a little insight into that. I think more in those details, Ian would probably be a really good person to talk to if you're looking for those.
Thanks. This, you sort of covered this a little bit, but I wonder if you have more to say about it. You know, you told us about the manufactured hailstones, about your new test protocol, and you know, you explained that that it's different, and you explained that it's different from dropping steel balls and using UL 2218. You talked about how the steel balls crush the granules and the hailstones displace them. Can you quantify what the manufactured hailstones get us in terms of predictive power, the ability to predict, you know, quantify the better ability to predict damage in nature? You know, I understand better and I understand more accurate, but I wonder if you can quantify how much better, how much more accurate, you know, in light of all the other, you know, random variables that go into a hailstorm and damage to a roof.
So if I get this correctly, you're asking the accuracy of our test protocol versus UL with what's actually in the field, correct? What's actually happening to roofs?
Well, I guess I'm asking how much this is your manufactured hailstones are more realistic. They simulate nature more realistically than do dropping steel balls. And more realistic is great, but how much better does that, how much does it get us in terms of the ability to estimate, better ability to estimate loss in future hailstorms?
I mean, our like I said, they're more, like we mentioned, they're more realistic. It's sorry, I think I'm just having a hard time answering the question.
Yeah, no, and maybe there isn't a good answer. Maybe that, you know, that's a question for another research project. You know, it's great to get a more realistic laboratory, a laboratory experiment that simulates nature more realistically. But you know, I'm thinking about, okay, well, does that mean that when I test stuff with UL 2218 that you know, that I need to switch over to this elaborate, expensive, sophisticated test protocol that you've developed? Or, you know, I mean, why would I not just say, well, you know, there's so many other random variables out there that maybe the steel ball versus manufactured hailstone doesn't matter so much. I would like to be able to tell myself it doesn't matter so much in the big scheme of things because there are so many other variables out there that produce other kinds of error. And I want you to tell me why that is wrong or why that is right, or what you think about what you've bought with this more sophisticated protocol quantitatively. And maybe you can't. I mean, maybe that's just a question that you can't answer yet.
Yeah, I think at the moment, I personally don't know. Something that just came to mind. I don't know if it's not necessarily on the quantitative side, but just more of the kind of the test standard itself. But this is being pushed into an ASTM standard instead of UL 2218. And we have provided a way for other companies we have a big hail machine, like you said, it's expensive stuff. We do have a single line hail machine as well. That is less expensive. And it's a replica so that other companies can, if they want to do this testing themselves, they can get that design and they can get a single line hail machine. There's UL actually already has one, and then PRI also has one as well, so they can conduct this testing.
What does it cost? I know how much it cost me to build my own UL.
That I don't know off the top of my hand. We worked with Accudyne, but off the top of my hand, I don't know the price of that.
Okay. Greg Steed asks, would the IBHS lobby regulators that control the testing process for impact classes of shingles? Would you lobby regulators to switch testing processes to better represent hailstorms?
Sorry, I'm reading it again.
Maybe another way to ask it is, are you doing any lobbying? Are you saying our test protocol is better and everybody should use it, and there ought to be some regulatory action to say,
I think we're definitely. I think we're definitely trying to push it, but again, I don't want to be the person that, like, I don't want to tell them what to do. But I mean, we have noticed that it is a good representation of hailstorms. But yeah, we are trying to put it out there and make it public.
Well, I don't have any other questions, at least nothing important enough to trouble the entire audience with, and nobody else is asking questions, and there's nothing that says we can't end a little bit early. So do you have any final thoughts that you'd like to leave us with? Is there any one big takeaway that we ought to take away from your talk?
Small hailstones do affect your roofs. They do lead to roof degradation, maybe a little bit faster than natural weathering. But just kind of be mindful of even the roofs that you've got on, the shingles that you've got on your roofs, and maybe the areas that you're in. Take a look at that granule loss. Be mindful of any incoming hailstorms that have large hail. I would love to see like I mentioned in one of my last slides, I'd love to see this kind of go down like a water entry project, and just see if there's any issues there and what more we can do with it. But yeah, just trying to shed light on the small hail issue and the granule loss problem and trying to solve it.
Wonderful. Okay, Brenna Meisenzahl, thank you so much for talking to us today. Thank you so much for this really interesting and important research. I will continue to watch the progress of this program with great interest. Thank you everyone else for attending today. Just please remember to join us next time on October 20th, when Becky Denlinger, Veronica Scotti, and Matthew Godso will speak about modernizing Canada's disaster financial agreement arrangement. Thanks, everybody. Bye-bye.
Thank you. Thank you.